Hi boys and girls, we are going to take a look at a hundredths chart today that I have actually added in one other digit that's often left off of our hundredths chart, and we are going to use it in a way that's a little different than what you're used to, even though you've seen this probably tons of times in your history as a math student. But we're going to actually look at numbers 0 to 100, and we're going to classify every single number in a very speedy fashion as prime or composite, because that is something we are expected to be able to do as fifth graders, and it's a great opportunity to really practice a whole lot of classifying of prime and composite and being ready for any number that might pop up on a graded assignment. So we're just going to jump right in. First, we're going to have a definition of prime and composite, which you should know by heart at this point. That would be prime numbers are those that have exactly two factors, one and itself. So there's no other multiplication fact that will give you the number other than 1 times itself. Short word, short amount of factors. Composite, long word, lots of factors. So that means it has more than 2 factors. And it's going to be 1 times itself, obviously, but it's going to have at least one other way to make it. So if you can think of another fact for that number, then it is going to be a composite number. Now, there is a super helpful box that we're supposed to know about whenever we're doing prime and composite problems. We want to know the special numbers that go in this box, because that will help us throughout all of this classifying process. So, what are those numbers? 4 digits that go inside of this box. 2, 3, 5, 7. Good job if you were able to say all those. 2, 3, 5, 7 are our prime and composite super secret trick box, whatever you want to call it. Here it is. That's what's going to help you. So, to start off, when we look at 0 through 9, what makes these different than every other number on this chart? Why are these numbers different than every other number on this chart? If you said it's because they have a single digit, then you're right. Every other number on here has 2 digits, or 3 if you get all the way to 100. So, these are our single digit numbers. Will a calculator help us on single digit numbers? Absolutely not, Miss Brown. We will never use this on our single digit numbers, because single digit numbers are the quick and easy ones. First of all, there's 2 lonely numbers that are neither prime or composite. Let's get rid of both of those right away. Neither prime and composite. What are they? Gone. 0 and 1 are our lonely numbers. They are neither. They do not count as prime or composite ever. All right. So then let's jump into our other single digit numbers. What's the rule? How do we know if there's prime or composite? We could think about their facts or their factors, or we could just use the little trick Miss Brown told us, and that is if it's in the box, it is prime, and if it's not in the box, then it is composite. So, single digit numbers. 2 in the box, prime. I'm just color coding, so pink and green. 3 in the box, prime. 4 not in the box, composite. Why is it composite? Because of 2 times 2. Alright, 5 in the box, prime. 6 out of the box, composite. Why? 2 times 3. I heard somebody say it. Good job. 7 in the box, prime. 8 out of the box, composite. And can you give me a fact? 2 times 4? Good. Alright, 9 out of the box, composite. And can you give me the fact? One everybody forgets? Yep, 3 times 3. Good. Alright, for the rest of these numbers, let's classify them. Let's go. As soon as we hit 2 digits, what should we be writing on our thinking paper? The number and our super secret trick box, whatever you want to call it, 2, 3, 5, 7. Now, I could write 2, 3, 5, 7 under every single number on this chart. I could grab my calculator and I could type the number, let's just take 13, and I could divide it by, because remember we're dividing, we're working backwards, 2. It's not going to work because it is odd. Clear it out. 13 divided by 3. It doesn't work. It's giving me that decimal blah blah blah. We don't want a decimal blah 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 when we're doing prime and composite. Okay, that didn't work. And 13 divided by 7. That didn't work. Decimal blah blah blah. So this is a prime number. Now, before I have to go through all of those, because this would take us all day, right? Well, not all day. It would take a really long time to do that trick on all these numbers. You would not be normally classifying 100 numbers at one time, but Miss Brown got a little excited and grabbed the hundreds chart, and this is what we're doing. So, let me give you a super fast way of doing this. Let's think about what's going to happen on this chart when we take a number and divide it by 2. You should already know what type of numbers are divisible by 2. What type of numbers are divisible by 2? Not prime and composite. I just gave it away. Not prime and composite. That's not what we're talking about. If we're talking about being divisible by 2, we are talking about even numbers. Y'all remember that? So, even numbers are divisible by 2. So, if we take a look, there's only one even number up here that was prime, and that's right here. 2 is your only even prime number. Right there. This like wins an award, okay? 2 is your only even prime number. Why? Because as soon as we get to double digits, okay, we already took care of the 6 and the 8 and the 4. They were all composite. But as soon as we get to double digits, if I take this calculator trick, as soon as I do my number, let's just take, for example, 52. As soon as I divide that by 2, I'm going to get a whole number and be done, and I'm going to label it composite. Okay, let's pick another number. Let's go over here to 68. As soon as I take 68 and I divide it by 2, alright, then I would have my little box set up, 2, 3, 5, 7. That's going to work every time. So, real quick way to classify all these 2-digit even numbers, they're all composite. Because even numbers are divisible by 2. Y'all learned that already. Let's use it to our advantage. They're all going to be composite. The only even number that's prime is 2. And we know that because it's in the box. Every other even number is automatically composite. Woo! Just saved you a lot of work. Check that out. They're all composite because if I use this right here, divide by 2 on all of them, I'm going to get a whole number because they're even, they're divisible by 2. It works out perfectly. Alright, now, the nice thing, the not so nice thing is, that does not mean the rest of these are prime. Sorry, your life's not that easy. So, we go back to our numbers. You could, if you knew absolutely 0 multiplication facts, this is the only thing you can do. If you know absolutely no multiplication facts at all, this is what you've got to do for the whole chart. However, we're working together today. So, let's hear some multiplication facts. Anybody got a fact for anything on here? 15. Everybody should know a fact for 15, right? What's a multiplication fact for 15? Oh, somebody said 3 times 5. Ding, ding, ding. If you can think of another way to multiply and get it, it is composite. If you can think of another way, it's composite. Done. Anybody else know some multiplication facts? Let's hear them. Oh, somebody said 3 times 9. 3 times 9 is 27. Composite. Can you think of another multiplication fact? How about your 11s? Everybody loves the 11s. What's 11 times 1? 11. 11 times 2? 22. 11 times 3? 33. Well, there we go. There's a fact that makes 33, which means that it is composite. Anybody got another one? 11 times 4 is 44. Where's 44? Oh, we already got him. He's even. 11 times 5, somebody said. 11 times 5 is 55. Composite. 11 times 7. 77. Composite. Alright, what else we got? 11 times 9. Good, you're on the right track. 11 times 9, 99. Y'all are on it. Alright, anybody else got a multiplication fact for any of our blank boxes? We got all these blank boxes. How about 25? That's a good one. 25. 5 times 5. Oh, our 5s. This is an interesting column to look at. If I'm doing my 5s, let's see. 5 times 5 is 25. Let's count by 5s. 5, 10, 15, 20, 25, 30, 35. Well, that's 7 groups of 5. 5 times 7 is 35. Well, then what's 8 groups of 5? 40. 9 groups of 5. 9 times 5 is 45. There's another multiplication fact for this number, which makes this number composite. Wait a minute. If I'm counting by 5s, 5, 10, 15, 20, 25, 30, do you see me bouncing back and forth between these columns? That means all of these are going to be divisible by 5. So all of these are going to work out if I divide them by 5. When I get to this rule when I get to this rule right here, they're going to all be circled. Okay? So, now, our chart's looking pretty done almost. Here we go. Alright, this is great. Anybody else got a multiplication fact for any of these numbers? Let me look down this side. Looking for multiplication facts. Anybody got one for over here? Oh! I heard somebody say 9 times 9. Ding, ding, ding! 9 times 9 is 81, which means 81 has a fact other than 1 times itself. So 81 is composite. Okay? How about this column? Anybody got anything for here? Nothing? Oh, there's one in that column that you should know a fact for, but we're going to skip it for now. Alright, let's go over here. Anybody got one for over here? Nothing? No, nope. How about over here? Got nothing? Oh, 7 times 7. Somebody said 7 times 7. Here we go. 7 times 7 is 49, composite. Alright, now, for the rest of these numbers, you don't have that many left. For the rest of these numbers, if you cannot think of a fact, does that automatically mean it's prime? No, it does not automatically mean it's prime. It means that you have no choice but to grab your calculator to test it out. So, for the ones that are left, we've got to work through our rules. So, we're going to do a couple together, and then your job is going to be to take this multiplication chart that you have, this hundreds chart that you have in front of you, and classify the rest of them on your own. Okay, this will be a great resource for you to have. So, let's take a number. Let's take 43. So, under 43, let's write 2, 3, 5, 7. And let's work it out. 43 is not going to divide by 2 because it's odd. 43 divided by 3. Decimal blah blah blah. 43 divided by 5. Decimal blah blah blah. 43 divided by 7. Decimal blah blah blah. So, none of them works, which means 43 is prime. Okay? Let's go to one that tricks everybody all the time. Let's go down to 93. No, I don't know. 93 and 87 are both good ones. Let's try to squeeze both of them in. 2, 3, 5, 7. 2, 3, 5, 7. Last two that we'll do together. 93 is not divisible by 2 because it is odd. So I slash that out on my thing. Make sure you're tracking this right here, guys. This is very important that you track this. 93 divided by 3. Ooh! I can circle that, and if I circle it, then it is composite. It worked. See how it worked? It's got a whole number here. That means that 3 times 31 will give you 93. Composite. Alright, let's go over to 87. 87 divided by 2. Woo! Did not work. Gave me a decimal 5. That won't work. Cross it out here. 87 divided by 3. Ding, ding, ding. Gave me a whole, oops, y'all couldn't see that. Sorry. 83 divided by 3. Oh, sorry. I don't even know what we're doing. 87 divided by 3. There we go. 87 divided by 3 gave me a whole number, 29. What that means is that 3 times 29 is 87. This is composite. So, for the rest of these numbers that you don't know facts for and we can't go through, you would have to run your 2, 3, 5, 7 rule. So, in all your spare time, feel free to fill in your 2, 3, 5, 7s and to classify the rest of these, and classify the rest of these as prime or composite just by shading them in one of your two colors. Great, great, great practice. Great way to prepare for your prime and composite tests that is going to be coming up very soon. So, there you have it. Didn't quite make it in 10 minutes, but we were pretty close. Thank you.